Welcome back. This will be the rest of 9.4, and I want to begin by having you note the amount of rotation formula that can be found on page 966. If you would like to see how they derived this formula, read page 966. It's pretty amazing to behold. Anyway, the formula is that the cotangent of 2 theta equals a minus c over b from our non-degenerative formula or form that we discussed earlier in this lesson. For example 3, we can see that there is a radical in this equation. This changes how we would use the non-degenerative formula. There are a couple of ways we can go about doing this, and the first way for you to learn is to be able to rewrite this in standard form. So when we are finished, we should have something that looks like the equation for a circle, an ellipse, a hyperbola, or a parabola. We're going to follow the steps from the top of page 967. And the first step is to use this formula with the cotangent. We can see that A equals 7, B equals negative 6 rad 3, and C equals 13. So we can plug them into the formula cotangent 2 theta equals A minus C over B, like so. Then we need to solve for theta. I will begin that by simplifying the numerator and rationalizing the denominator. Actually, I am not going to rationalize the denominator because I think it will be easier for us to see theta this way. So if we think about cotangent, let's ignore for a second that it's a double angle, and let's just think about a regular angle. Cotangent is cosine over sine. So we need to think about where on our unit circle we're going to end up with something having the square root of 3 in it, because when we divide, we're going to end up having that. So if we look at the 60-degree angle, we can see that the cotangent of that does end up being 1 over the square root of 3 after we simplify. If you need to pause for a moment to calculate that yourself, please feel free. Then when we realize that this is the cotangent of a double angle, so the cotangent of 2 theta equals 60 degrees, then we know that we are looking for theta to equal 30 degrees. This completes step 1, and now we are ready to use this for step 2. I'm sorry, I misspoke. That actually completed step 2, and we're now ready to use step 3. We are going to use theta equals 30 degrees in the rotation formulas. We plug in 30 degrees in the formula, and then we simplify using what the cosine and sine of 30 are. As you may remember, the cosine is the square root of 3 over 2, and the sine is 1/2. First, we plug it in to find the x value on the rotation, and then we plug it in to find the y value of the rotation. For step 4, we're going to take the x and the y that we just found in step 3 and put it into the very original given equation. So each x and y that was in the original equation has now been replaced with the x and the y that we found in step 3. From here, I'm going to go ahead and perform the squaring of this and this. Oops, there we go. And I'm going to FOIL these. So I have FOILed and squared appropriately. You'll probably notice there were a couple of fractions that I did not simplify, And the reason is because, oops, I just noticed a mistake. There we go. Is because everything has a denominator of 4, or in the case of 16, the denominator is 1. This means I can just multiply everything by 4 to make the fractions go away. If you do not feel comfortable with that, just go ahead and distribute and then combine like terms. But I'm going to get rid of the denominators before I distribute. And really all that does, once I multiply everything by 4, it makes these 4's go away. It makes these 4's go away. It makes these 4's go away. And it makes this be 64. Everything else stays the same. And then I can go ahead and distribute and then combine like terms. So let's distribute. After distributing, I get 21x prime squared minus 14 rad 3x prime y prime plus 7y prime squared minus 18x prime squared minus 18 rad 3 x prime y prime plus 6 rad 3 x prime y prime plus 18 y prime squared plus 13x prime squared plus 26 rad 3 x prime y prime plus 39 y prime squared minus 64 equals 0. I only read all of that because I can see with the stylus my handwriting leaves something to be desired. So now we combine like terms. Many of our terms canceled out and we were left with 16x prime squared plus 64y prime squared minus 64 equals 0. So I'm going to go ahead and set this to equal 64, which makes this go away. All I did was add 64 to both sides. And then I'm going to divide by 64 because I want standard form. And I end up with x prime squared over 4 plus y prime squared over 1, which I do want to show for graphing sake and to be in standard form, equals 1, which we can see is an ellipse, which we don't have to answer that for this problem, but we could recognize that that's what this is. Go ahead and try checkpoint 3 and come back to see if you did it correctly. Here is what you should have gotten for checkpoint 3. If you did, congratulations. If you did not, please just go back and recheck your work and hopefully you can see what might have gone wrong. Also make sure to bring me your specific questions about this to class tomorrow if you cannot find your mistake. Now let's go on to example 4. Example 4 has us do what we did in example 3, but then also graph it. So for example 4, the first thing you need to do is follow all of the steps that we just followed. And then after you do that, you will end up with y prime minus 2 quantity squared equals negative 2x prime. We can see by looking at this that this is a parabola. Just a reminder of what a parabola looks like in standard form. I have written it for you here. And we can see that h equals 0 and k equals 2. So this means that our vertex is at 0, 2. We can also see that p equals 1/2. And this puts our focus at negative 1/2, 2. We do not need to worry about the directrix for this. Also, when you were going through the steps for this, you should have found that theta, the angle of rotation, approximately equals 53 degrees. This was not exact like the one we did in example 3. This one you would need to use one of your arc functions. So depending on what you came down to, you could do arc of 1 over tangent, or you could do arc cosine over sine, or something like that, but you should have ended up with around 53 degrees. So then we go about graphing. Here is the traditional axis, In red, I'm going to draw approximately what it would look like if we rotated it 53 degrees, about like that, and we're going to go ahead and just graph the parabola on the red set of axes. I will start with my vertex. This is my x prime axis, by the way, and this is my y prime axis. So 0, 2, I'm going to go ahead and switch to black here. 0, 2 would happen here. And then my focus would happen really close to it, about right there. Sorry, this isn't the best depiction. And then we also need to think about our latus rectum, which is going to be 2. So from the focus, I'm going to go one this way and one this way, and then just go ahead and connect those. Sorry, that's not the best, but you know what that should look like. I'm just going to go ahead and connect those and graph them the same way that we have been graphing parabolas all along, just on a new axis. All right, go ahead and pause this and do checkpoint 4, and then come back for example 5. In example 5, we learn how to identify a conic without having to rotate the axis. We can do this from a non-degenerate equation with this formula. The times that we would use this formula are if our non-degenerate equation has a radical in it, like example 5. When there's a radical, we need to use this equation, and that is b squared minus 4ac. If it equals 0, it's a parabola. If it's less than 0, it's an ellipse. And if it's greater than 0, it's a hyperbola. So in example 5, we can see that A is 11 and C is 1. And with the formulas we learned at the beginning of this lesson, we would be tempted to say this is an ellipse because 11 times 1 is positive. However, the radical in this problem changes everything. So with our b equaling 10 rad 3, let's look at what happens. We can see when we plug this in that we end up with 300 minus 44, and that is greater than 0, so we actually have a hyperbola. Go ahead and try checkpoint 5 and come back. For checkpoint 5, you should have gotten that it is a parabola. If not, go back and see if you can find your mistake, and again, remember to bring me some specific questions for tomorrow's lesson. This completes lesson 9.4. Please try problems 1, 3, 11, 15, and 39. Compare your answers to those in the back of the book, and come to class tomorrow with specific questions. Also, be prepared to work on the 9.4 assignment that I will be giving in class. So if you come after taking notes on this video and trying out the checkpoints and trying out the problems, you should know how to do what we're going to be doing in class, and we can all work together.